So welcome everyone. We are live from Durham Public Schools, particularly from R.N. Harris Elementary School in Durham, North Carolina. We're running about 3 minutes late, trying to get the kids from R.N. Harris seated. So if you will hang on for us out in TV land, we will be on in just a few minutes.
No, I wish we could, but we're not class. Quickly, look in front of you a little bit.
Belton is here now.
Okay, I think
People in Durham, North Carolina. We're running about 3 minutes late. Trying to get the kids from R.N. Harris seated. Okay, so YouTube is up and going. It's going to have a 2-minute delay, which is fine. I'm going to get them seated. Okay, guys, I need you to come in quietly, get into your seats. Quickly. Belton, can you pull up your computer out there real quick? Yes. And print it real quick. Okay, we're not waving right now. Remember, we'll have a moment to do that. We're already live, guys.
We're already live. Let's go. Quietly. Up front. Shh.
So, we're getting ready to start. Okay, so let's go ahead and just start talking for a minute. For those of you joining us by YouTube, you're on a 2-minute delay behind me, but if you will type your questions in the chat bar, I will monitor that also and get your questions up as quick as possible. And I would love to be able to monitor your, or Mr. Belton, if you could come up here and sit and monitor the YouTube account so you can do the questions there too. So you're going to print for me real quick?
Yes, I can print for you. See something?
Yes.
Print.
Okay, so here we go. So welcome again to R.N. Harris Elementary School from Durham, North Carolina. I'm going to give you a real quick look at our students, and they're going to give a real quick hello. So students, if you will take a moment and wave, and you'll look on the screen, you're already up there. So you're waving, you can see yourself up there. Excellent. Nice. So these are 5th graders. There are 2 classes, grades here. We're working on Weather Science Engaged today, and we are setting off hot air balloons a little bit later in the day, but we're here for one purpose, and to learn more about weather. So I'd like to introduce our guests to us, and we'll start on the left here with Jared. So Jared, if you will talk to us.
Hi guys, my name is Jared Rennie. I am a meteorologist and climatologist, so it's a little different than meteorology. I went to school up in New Hampshire. I got my degree up there, and now I work at a place called the National Climatic Data Center, which is actually not too far from Durham. It's about 4 hours west of you in a city called Asheville. So we're up in the mountains of North Carolina. So the National Climatic Data Center holds all of the world's weather data. So all the weather data you see in class, you see on the news, you see online, that all at the end of the day gets stored in our building. And that gives me the luxury to go back and play with all the data. So I can tell you what the high temperature was in Durham on, let's say, July 4th, 1776, if it was available. But we have the luxury of doing that. So my background is in meteorology, but with more of a focus on climate, and we do a lot of math, a lot of science, and a lot of programming, so software engineering. I've been there for about 4 years, and I actually work for the state of North Carolina. So the National Climatic Data Center has a lot of federal employees from NOAA, which is the National Oceanic and Atmospheric Administration, but we're a cooperative institute, so we're more on the academic side, and we help the federal employees with their work.
Thank you very much, Jared. So we'll next go to Ricky.
Hey there, everybody. I'm Ricky Matthews. I'm a meteorology major at UNC Charlotte, a little bit to the west of you. We're one of 3 universities in the state of North Carolina that has a meteorology program. NC State has one, UNC Charlotte has one, and UNC Asheville has a program, and East Carolina University is just starting up a program, but we've had our program here at UNC Charlotte for about 10 years. It involves a lot of math, a lot of physics, a lot more kind of in-depth than what most of the science classes you'll take over the years go into. Instead of focusing on different topics in science class like you guys do throughout the years, we focus basically just on meteorology. And all of our classes are dedicated to meteorology and the science behind them and how we can learn things to use them in the future. But this will be my 4th year here at school. I hopefully will graduate in May and looking to do something with either broadcast meteorology on TV or maybe something with aviation weather. So excited to be here.
Thank you, Ricky. We appreciate you being here today. And next we'll go to Steve.
Good afternoon. My name is Steve Monday, and I'm with Rowan County Weather. It is a privately ran weather site that I utilize for the folks in Rowan County, North Carolina. And what I do is work with the group NBC Charlotte called the first storm spotters. We just kind of cover areas in the Charlotte metro area. Do a lot of work with Ricky Matthews, Brad Panovich, and just excited to be part of it. And anytime check us out, you can follow us on Facebook, Twitter, and we provide up to the minute forecast and just kind of take a different look at it from really a forecasting standpoint with our meteorological side of things as well.
Thank you, Steve, and thank you, Ricky, for muting that mic for us. We'll take care of each other with that. And then if we'll talk to our Yellowstone Ranger.
Hi, everyone. I am Ranger Mike. I'm a Yellowstone Park Ranger. We're going to share a little bit of our weather with you guys. Can you hear me okay? Can you guys hear me?
Yes, we can hear you.
All right. So just wanted to say welcome. We are not in North Carolina, but we're actually in Yellowstone National Park, at least 2 time zones and well over 1,000 miles and probably several thousand feet higher in elevation. So as a park ranger, we have to deal with the elements, and that's why we're here today, to share a little bit of a different weather system here at the raised plateau of Yellowstone National Park.
So thank you, guys. We appreciate this. I'm monitoring comments and people online right now. So we have close to 1,000 kids that have already joined us, and we have a few that are coming in a little bit late. So our first question is coming from W.G. Pearson Elementary School and in Mr. Shabrack's classroom. And the question is, what are the differences between cold fronts, warm fronts, stationary fronts, and occluded fronts? And so I'll just start with Jared, and then for this part, we'll just jump in on top of each other. So if you finish talking and somebody else wants to jump in, please feel free to do that.
Well, in order to understand front, the first thing you do is think about air mass. And there's many different air masses. There's cold air mass, warm air mass. And then there's also, you can even hone it down even more to a cool and wet air mass or cool and dry air mass, and a few others as well. So the front is essentially the boundary between the two. So essentially a cold front is when you have, for example, let's just say North Carolina, you're in an area where it's very warm. And then a cold front is sort of a barrier between that warm, moist air and cool, dry air that's behind it. So the way the physics works is that the cold front will essentially, in our area, move from west to east, and it usually brings cooler, drier air behind it. But with any front, there is some sort of weather-related event that you can get. And normally with cold fronts is you get quick, you get quick changes in wind shift and precipitation. So you normally have a nice line of some sort of weather, whether it's precipitation or some sort of thunderstorm. A warm front's a little bit different, where it's kind of almost the other way around, where you're in a cool area and you have this warm air mass kind of coming over into your area. And so with the physics behind that is that you get more of a longer period of rain that can last for a very few hours. A stationary front is similar to a cold front and a warm front, but it doesn't move. The first two fronts, there's some sort of air mass moving from one direction to the other. In a stationary front, they're not necessarily moving. That's why we call it stationary. So in that case, you still get some sort of precipitation, but it kind of usually hangs over your area. So you can get very long areas of precipitation for a very long time. And then in an occluded front, that's sort of the trickier one, where you have a cold air mass moving faster than a warm air mass. And it kind of, it's a little hard to explain, but it usually occurs around a low pressure system. And so the cold air moves faster than the warm air, and that's where you get sort of an occluded front. And you still get areas of precipitation in that event. And the best way to kind of depict the difference between all of them is to look at certain variables across the U.S., including temperature, pressure, and wind. And not only when we talk about the wind, not only the wind speed, but also the wind direction. So that's kind of a basic overview, and anybody else feel free to jump in.
I think one of the important things to mention, Jared, is most of the times when we get those big lines of thunderstorms that come through here, we'll have a day where maybe we'll talk about on TV with severe weather potential. It's usually those cold fronts that are pushing through our region that are giving us the chances of severe weather. So when you see the weatherman on air and saying there's a cold front coming in, oftentimes you can expect much colder weather behind it and the potential for some thunderstorms as the front moves through.
All right, thank you guys. So we have another question coming in from Mangum Elementary School in Bahama, North Carolina. And it's from Ms. Carpenter's class. And Dalton wants to know, what makes a supercell? Who wants to take that one?
I'll take that one. A supercell is basically a thunderstorm that is self-sustaining. Thunderstorms by themselves have winds that are moving around inside. We have what's called updrafts and downdrafts. And so in a supercell, you have winds that are rotating. And most of the time when you get supercells, you talk about potential for tornadoes, very large hail, very heavy rainfall, and some very strong gusty winds. And around North Carolina, we don't really see supercells that often. They're more common out in the plain states and over the Tornado Alley area, but a supercell is a storm that has a rotating updraft and is able to self-sustain itself, unlike other types of thunderstorms that are more dependent on the other types of storms around them and the environment around them to see if they're going to be able to continue or if maybe it'll die out and a new storm will form from the previous storm. So, anyone else want to add anything?
Okay, thank you, and thanks for that question, Dalton. Now we're going to have a question live from RN Harris. So Mr. Belton's going to choose the student right now, and I'm going to let him come up to the camera. So if you'll tell who you are.
Hello, I'm Ezekiel Leap. Our question is, can you please explain El Niño, La Niña, and Gulf Streams?
All of them at the same time? That's a hard question. I like it. All right, so his question was, again, can you please explain El Nino, La Nina, and Gulf Streams? So, Steve, we'll head over to you for this one if that's okay.
Sure. And so, yeah, there's a couple of different ways that works. You know, El Nino and La Nina really, it's all about how the flow of wind goes, and really, you know, I hate to kind of pass the buck off, but really the meteorological student in the room, probably Ricky Matthews, could give you the more technical terms of it. You know, from a forecasting standpoint that I do, I really look at those for more of a long-term standpoint to, you know, for like winter forecasting, things of that nature, like you've seen that's coming up, you know, where we're handing out long-term forecast and things of that. But for the technical standpoint, Ricky, I think you could probably give a much better answer than I'll be able to.
Someone can probably give a better answer is Jared, because he works with climate, and that goes a lot into climate data.
All right, Jared, I see that you've shared your screen with us. Do you want to talk for a second?
Yeah. Can you see the whole image there, or is it kind of cut off?
We got it.
We can see it.
Okay. So I can talk a little briefly about El Nino and La Nina. So they are both associated with something that we actually like to call ENSO. So ENSO is an acronym, and that actually stands for the El Nino Southern Oscillation. So when you think of oscillations, let's talk about this first. In a day, you have warm temperature during the day, it's sunny out, and at night, you know, it cools down, so it goes down. So essentially, there's oscillation of temperature. Warmer during the day, colder during the day, colder during the night. So that's an example of a daily oscillation. So around the globe, we have other oscillations as well. We actually have many, and they usually, with each oscillation, they have some sort of effect on some type of the globe. So we call that actually a teleconnection. So this oscillation, the El Nino Southern Oscillation, occurs over in the Pacific, the southern part of the Pacific Ocean. And there's an area of temperatures in the water, so the sea surface temperature, that will, at some points, it's usually warmer than normal or colder than normal. And it covers an area of a few thousand miles across the Pacific Ocean. So that's where we look at when we try to determine this oscillation. So when the temperatures are warmer than normal, that is what we call an El Nino. So that's kind of like the top part of the oscillation. And then when they're cooler than normal, that's what we call La Nina. So that's sort of the oscillation El Nino and La Nina. Now that doesn't happen daily like it would do with your temperatures. This happens on a scale of a year or so, and it could be multiple years as well. So this graphic that I have shared here kind of talks about what happens, at least in the United States, during El Nino and La Nina events. So in an El Nino event, which is on the top, you usually have very warm conditions across most of the United States. One of our past few El Ninos, we had a really big one during the years of 1997 and 1998. And as a result of that, we had very warm temperatures across the United States, warmer than normal. Excuse me. So as you can see, we have this sort of low pressure system across the Pacific Ocean that sort of induces warmer temperatures in parts of Alaska, Western Canada, and the northern United States. And then what it also does is it creates this sort of persistent jet stream. So a jet stream is like a highway of wind in the upper atmosphere. And it kind of goes really fast from west to east. And what that does is it picks up all the moisture from the ocean, and that moisture will sort of come over land and create precipitation, which is why in the southern part of the United States, it's much more wet. We get wetter conditions over parts of California, Texas, in the Gulf states, and even parts of Mexico. So what kind of happens in North Carolina is we're kind of smack in the middle of this sort of this wet area and warm area to the north. So we actually sort of see a sort of a drier than normal event in our area because of El Nino. Now, on the other side with La Nina, because the temperatures are cooler than normal in the Pacific, and actually instead of it creating a low pressure, it creates a high pressure. So it kind of creates this sort of blocking system that kind of brings this jet stream. It's not as persistent, it's not as strong, and it's more variable. And what that actually does is it brings cooler temperatures across the northern part of the United States. And as you can see in the southern to southeastern part of the U.S., it does a few things, depending on where you are. In our area, we're a little bit warmer than normal, and then areas that are normally wet during an El Nino season are actually dry. So that's kind of a basic overview of what happens during El Nino and La Nina. I'll let anybody else jump in if they want.
Well, I think you did good on that. Thank you so much. So we have a group of students, about 400 students from Saskatchewan, Canada. And this question is for, I guess we'll throw it to the Yellowstone dude. And just wants to talk about the weather right now and what your climate and weather is normally.
Hi, and hi to Canada as well. Probably use most of Fahrenheit with most of our discussion, but we can obviously see Celsius. Currently it is about 11 degrees Celsius or about 53 degrees Fahrenheit. Can you guys still hear me? All right, great. I was just getting a little bit of feedback, but that's awesome. So our climate is going to be a little bit different. We're considered a raised plateau. We're, as average, over 6,000 feet above sea level, or, approximately over 2,000 meters. Nope, I did that wrong. Nope, that's about right. 2,000 meters at sea level, above sea level. So we're a raised plateau, so we are much cooler. When it comes to most of the United States, especially the folks down in North Carolina. We've had frost almost every morning for the last week or so. It's not uncommon to have October blizzards or snowstorms. We actually can receive snow all 12 months of the year. And last year and this year, we had a higher than average snowfall. So we did have traces of snow, especially above 3,000 meters or above 10,000 feet. In August this year. So we're relatively cooler than the most, and that's because we're farther north, but also we're in a higher elevation. And both of these things affect our climate and our weather. We do have areas that is considered alpine desert. So we do have cactus in our northern range, and that's about 5,000 feet above sea level. So our lower area, farther north. We even have a desert or desert-like climate where we do have prickly pear cactus growing in Yellowstone National Park. So overview, that's about it. And so it's not uncommon, if I can try this, in Yellowstone National Park. If you come in the wintertime, you'll see much more snow than on the average. So this is one of our major signs in the wintertime. Some areas can get over 10 feet of snow or over 3 meters of snow in the interior. Up here in Mammoth Hot Springs, we're a little drier and a little bit warmer. But this photo is actually from May last year.
Wow, we don't have that kind of snow here in May. So another question from Albuquerque, New Mexico, and this is just asking for anybody to talk about hurricanes. If they've been in one, or if they've been affected by one, they would like to know a little bit about the hurricanes. So who would like to talk about that?
I'll gladly take that one because I grew up on it. I've been through 3 hurricanes and 1 semi-hurricane. You may remember Superstorm Sandy from last year in the news. In Virginia, we get a lot of coastal impacts from that in terms of flooding and some wind and rain from the storm. But hurricanes basically are a low-pressure system that forms over water, and it ties into the heat of the tropics and ties into the atmospheric conditions over the ocean for its strength. And when hurricanes come, move up, impacting portions of the land, especially across North Carolina and Virginia, the Outer Banks usually get a lot of hurricanes. Florida used to get a lot of hurricanes. It seems like they're in a hurricane drought right now. They haven't had a storm in many years down there. But when a hurricane makes landfall, there are many factors that go into the overall impact. You have heavy rainfall. You have gusty winds. With a hurricane, you have sustained winds over 74 miles per hour for the whole length of the hurricane on a 1-minute average. So you have also a storm surge, which is where the ocean water actually comes onto land and causes coastal flooding. You have the risk of isolated tornadoes, and you also have the risk of wind damage from those winds that I mentioned earlier. And so I was actually in the eye of Hurricane Arthur earlier this year when it made landfall in North Carolina. It made landfall near Beaufort, North Carolina, and when you go into the eye of the hurricane, it's very calm. That's where the lowest pressure is inside the storm, and all the air in there is, all the air is rising, and you get very calm weather conditions inside the eye of the hurricane. On the outside, though, of that eye are where you're expecting your worst weather conditions. That's what we call the eye wall of a storm. That's where you get the strongest winds, you get usually the potential for the highest surge if the eye wall passes over you, and you also get the basically worst weather conditions you're going to find anywhere in the hurricane. But one interesting thing about hurricanes, though, they are the only weather system that we purposely fly into. There's a group called the Hurricane Hunters out there that fly U.S. Air Force C-130s and also fly P-3 Orions and a few other NOAA aircraft into the hurricanes to figure out weather information about them, because if we can gather more weather information, we send it back, it goes into our models, we make better forecasts. And the reason we have to fly into storms over the ocean is because, unlike here in the United States, where you may have a weather station in your backyard or there's a weather station at the airport, there's not a whole lot of weather stations out in the middle of the ocean. So we may have a few buoys out there, but there's not a very well dense network of weather stations out there to give us data like there is over the continental United States. So flying the Hurricane Hunters into the storm is very important for forecasting, and it's really improved our models over the last, what, I think it's 40 or something years, Jared, that we've been flying into storms.
Yeah, it's been a few years.
So thank you. That was a great question and great answer from Ricky. So I'd like to introduce another student from RN Harris, and he's going to tell you his name and give you what his question is. And okay.
My name's Samuel Thomas, and my question was, how do jet streams influence day-to-day weather?
Who wants to grab that one?
I can take that. Wow, that's a very good question. So the jet stream is, again, it's a sort of a area of very fast-moving winds. We don't experience them at the ground. We experience them a few thousand feet up. Actually, that's why it's called the jet stream, because it's usually at high enough where the airplanes are. And they're usually created by pressure differences up in the upper atmosphere. And they can definitely impact weather greatly on a number of occasions. I mean, even up in the upper atmosphere, you have winds as fast as a few hundred miles per hour. I mean, almost hurricane force winds. So that will affect airplanes. Sometimes they may not want to go into the direction of those because of something we like to call wind shear, where either the wind changes very drastically over a period, whether it's wind speed or wind direction, and that can sort of alter how the plane flies. But back down here on the surface, that can certainly there's specific areas of the jet stream where, due to its physics, it creates very fast rising motion. So that rising motion, once if an air parcel rises really fast, that's usually kind of associated with a low pressure system. And what it'll do is the air parcel rises, it cools as it goes up, it condenses into water vapor, and then once those condensate large enough, you get water droplets and you get precipitation. So essentially, the faster that upward trajectory is. Usually either the heavier the cloud or the stronger the system. And they're usually associated with, sometimes they're associated with fronts. You can get that extra forcing with a frontal boundary. But it can certainly impact how much weather you get. And depending on where you are in the country. In North Carolina, that would usually be associated with heavier precipitation. And in some rare cases, if it's accompanied by a very strong cold front, you can get some hail and some lightning with that as well. And in some cases, also very small tornadoes as well.
All right, thank you for that. And we have another question from RN Harris, and she's going to introduce herself and give you the question.
Hi, my name is Daphne. My question is, how do you find weather patterns?
Don't fight over that, boys.
Basically, to find weather patterns, we have to go back and look at the data over many, many years and try to figure out, first off, for climate data, what's the average of the weather during this time frame. We call that climatology. It's the typical weather that you can expect during the months of wherever you are. So typically, in the summer across North Carolina, it's usually pretty hot. We have the chance of maybe a hurricane coming up along the outwest coast. We usually see those thunderstorms during the afternoon hours. And in the winter, around here, we don't get a lot of snow, but climatology can vary per region. So if you go out west into the mountains, your climatology varies. You usually have cooler temperatures out there than you do along the coastline, and you have a chance for more snow in the mountains. And so when we look at weather patterns, we're looking at the climatology and we're looking at the overall structure of the atmosphere. We have what's called global models, and we're able to look at the structure and see where different features are across this whole world to figure out if a weather system is going to come and impact us or not, and whether that weather pattern is going to continue based off climatology and based off the trends we've seen over time. Jared, you have anything to add to that, since you're the climate and kind of expert in all that?
No, that sums it up. I mean, we have to look at many different variables to determine our patterns. That's how we sort of figure out how to place a cold front on the map, or a warm front, or a low pressure system. The essential variables we like to look at are surface temperature, the surface pressure, the wind, and that's two components: the direction of the wind, where it's coming from, and also the speed. And we don't just look at that at one area. We look at that in a region. So depending on who you're forecasting for, for North Carolina, we're going to want to look at the southeastern U.S. and even farther west out into Oklahoma to see what patterns are going out there in the Midwest to Central Plains. And then there's also on a national scale, if you're doing some forecasts for the entire U.S., you're going to want to look more globally as well at all the data we have. And so lots of data, lots of variables that we get to look at. And that's how and as Ricky said, we have to look at that over time to see, in a low pressure system, this is what happens. In a cold front, this is what happens. And we can only do that by looking at the past.
All right, thank you. So we're going to go to San Diego, California. And the question is just your favorite or scariest weather experiences. So I'll throw it out to all of you to jump in. Your favorite or scariest?
I tell you what, I'll start this part.
In Yellowstone National Park, one of the scariest weather incidents we have here is lightning. We do have mountain ranges, and it's not uncommon to be hiking above the tree line, and lightning strikes can propose a very dangerous situation. I was hiking with a bunch of teenagers this summer, and one of the teenage females, her hair started to stand up, and we immediately started to hike down. We were still below the tree line, but we were exposed. So no lightning strikes personally, but at least we were showing signs of that charge when her hair started standing up. So definitely some static charge was building. And as a park ranger, the best thing you can do is get indoors. So we commonly say when Runder Thors, go indoors. But in Yellowstone National Park, that's not always possible. So we did have, I don't even know if I would classify it as a lightning scare, But we definitely saw some static buildup happening on a hike, and we hiked through the middle of trees and stayed from the outside of the trees, and we waited it out. So we went down and protected ourselves to the best of our ability when we're out in the backcountry in Yellowstone National Park. So I just thought I'd share a little lightning safety real quick. And that's our major concern summertime at
Steve, did you have something to share?
Yeah, actually, I wanted to share. It's kind of ties into the hurricanes that we spoke of earlier. But one of my, I guess I would say it's my favorite weather experience is, I actually experienced Hurricane Hugo, but in a different type scenario. I experienced Hurricane Hugo here inland, in the Charlotte area. And just north of Charlotte, when Hurricane Hugo came through, of course, it's been over 25 years ago now. When that storm made it into the Charlotte metro area and just north of Charlotte up into Rowan County where I am, we were still getting hurricane force winds of over 100 miles an hour, even this far in. And, it's kind of unheard of to go through that. Saw some things that developed during that storm that really kind of caught my attention and made me want to really look into weather and really start to study it, just the phenomenon of it, and what causes things to, like the wind and all that, to get much stronger and these storms to be as severe as they are.
All right, thank you. So we just have a few minutes left, but I want to get a few more questions in. And so I have another question from RN Harris, and she's going to introduce herself to you right now.
Hi, my name is Jamie Bodie, and my question was, can you please explain the differences in how tornadoes and hurricanes form?
So when we in meteorology we talk in different scales. So there's a global scale, and then there's other scales like synoptic scale, which is like a regional scale, and then you go smaller than that to what we call the mesoscale. And then you can even go smaller than that, called the microscale. So in a tornado environment it's mostly a mesoscale phenomenon. It's also influenced by some synoptic forcing, whether it's something like a cold front or a different kind of front we haven't talked about yet called a dry line, which a dry line is essentially a boundary of not temperature difference but rather moisture difference. So it's dry on one side and wet on the other. But in a tornado environment, it's mostly formed in a small scale environment called mesoscale, and they're very hard to predict to some cases. We can use certain variables to tell people in a certain area where a tornado could form. On the other side, for a hurricane, it's more of a larger scale. So the diameter of a hurricane can be a few hundred miles. In some cases, they can be even larger or smaller, but they're a lot bigger than a tornado. Where a tornado is, it's only the size of a tornado is only maybe a few meters or something like that. They also form differently. So hurricanes form mostly over water, as we talked about earlier. The variables you need to get hurricane formation is it needs to be close to the equator, and you actually usually have very calm winds. You don't want any wind or strong wind in that area because that could break up the storm. And you want warm waters. You want warm sea surface temperatures. Tornado, the environments are a little bit different, where you have to have some sort of barrier, some sort of change in wind direction, and the wind here has to be usually strong. And changing with height. And you also have to have a strong temperature difference and a strong pressure difference as well. And there's a few other things as well. And those only form over the land. So there are a few differences between both of them. One is the scale, and one is the variables that kind of vary.
Another thing, Jared, may be important is the time they last. Hurricanes are lasting for a really long time. You know, we had Hurricane Isabel that made landfall in Eastern Virginia, and we were in the storm for over 12 hours. It started in the morning hours, and I went to bed that night, and it was still windy and rainy, and the water was still coming up outside. But tornadoes, on the other side, usually last for a much shorter amount of time. Most of the tornadoes, especially in areas along that don't see tornadoes that often or aren't in Tornado Alley, are the weaker variety of tornadoes. So they last maybe a minute or two, and they're done with. But you know, that minute or two is that they're on the ground can be very dangerous for when those winds are causing damage to the trees and the homes and anything like that. So.
All right, so obviously we want to stay out of those situations, but I know you guys like to chase that sort of stuff. We have enough time for you to each give us about 20 seconds of what you think these guys should be studying and working on in school, so if they decide they want to enter a job to be a climatologist or a meteorologist. I do want to say we've had questions from Forest View Elementary and Mangum and Sacramento, California, and Indianapolis, Indiana, and so I have about 50 questions that did not get answered. So your homework is that I'm going to send all these in the chat window later, and if you have time you can answer those and we'll send those back out. So just what would you encourage our students here, and let them do one more big wave here from RN Harris. These guys right here have been working really hard in science, and they would like to know what they should be doing in their classrooms and in middle school and high school to learn more or to become a meteorologist. So I will pass it on to you guys.
I'll take that one since I'm still in college here at UNC Charlotte. I'll tell you a little bit about what we do. If you want to be a meteorology major, you're going to want to make sure you do well in your math classes, especially in your science classes. Those are the main two things that come into play. When you get into high school, you're going to want to try to take like a physics course or higher level math classes, calculus, stuff like that. And you know, just now, when you're still in elementary school or in middle school, take weather observations. You know, ask your parents to get you a weather station, start recording the weather data that happens throughout the day, the high and the low temperature, and just start kind of watching what happens around the state. Because the best way to become the best type of forecaster and the best people who know the most about the weather are the people who look at it every single day and the most interested in it. So if you have a passion, follow it, because that's where the best meteorologists come from.
Yeah, definitely. I'll kind of chime in on the backside of what Ricky was saying as well. You know, first of all, he's right. Math, science on all levels. Those are the key things. You're going to utilize those a lot on a daily basis. And then beyond that, you know, not only the weather station, but also get involved, you know, as a weather kid. I mean, you know, you can be a weather kid with a lot of local meteorologists and local TV weather personalities around your area. Those guys are great at kind of giving you the basics and helping you understand what to get started with, and you'll end up developing more of a passion for it, you know, from that and just involvement in what you're seeing outside your window as well.
I'll add one more thing that the kids should be looking at, and it's some sort of spreadsheet software, whether it's Microsoft Excel or Apple Numbers or if it's Google Drive. Math and science, obviously you got to know that, but if you want to apply it, you want to use some sort of spreadsheet to kind of deal with large numbers. Whether you're in climatology or meteorology, we deal with numbers, and we plot those numbers to tell us what's going on in the atmosphere. And I think those spreadsheet programs are really good at handling large data and plotting it. And if you do end up getting a weather station and you have your high and low, plot that put that in your spreadsheet every day, and then you can plot it, and then you can see what kind of what's happening with your data. Data analysis. That's kind of a big thing that we do. That I do in my work, and I think that would help greatly.
So before my reading teachers fall on the floor, we know that you also reading and writing was just a given. We know that we need to be doing that all the time, and then that's sort of the basis of all this, and then that's where the science and math, because if you can't read well and write well, you're not going to understand the science and math of it. So just so they don't fall on the floor over here, I'm making sure that we put the plug in there for the reading and writing. So we want to thank you on behalf of Durham Public Schools for showing up today and helping us out. Like I said, we have tons of questions that did not get answered, but we'll try those for another time. And we thank you so much, Jared and Ricky and Steve and our Ranger Mike, and we hope that we can do this again with you sometime soon. So I'm going to have our kids tell you something.
Thank you. Thank you.
And thanks, guys. I really appreciate you working. I'm trying to manage the Twitter feed and the questions and the Google Hangout too, and it's kind of tough here, but we really appreciate it. And I'm going to go ahead and stop the broadcast, and I hope that we can link up again sometime, okay?
Great, and thank you very much.
Thank you.
That's good. Thanks.
Bye-bye.